Voyager 1 has traveled farther from Earth than any other human-made object, setting out in 1977 with a mission originally aimed at exploring Jupiter and Saturn. But this groundbreaking probe didn't stop there. By 2012, Voyager 1 crossed the boundary into interstellar space, sending back unprecedented data and capturing the imaginations of generations. For nearly 5 decades, it has been our silent envoy in the vast reaches beyond the solar system, gathering information about an environment no human will likely see up close. This mission is more than data collection, it's a symbol of human curiosity, pushing the limits of where and what we can explore. Recently, Voyager 1 faced a significant challenge. Communication issues arose as it continues to age and drift ever farther into the cosmos. On October 16, a routine command was sent to activate a heater, but Voyager's fault protection system went into action instead, turning off its primary X-band transmitter. As a result, NASA was forced to rely on a backup transmitter, the S-band radio, which had been dormant since 1981. Given the distance Voyager 1 now travels, over 15 billion miles from Earth, switching to a backup transmitter that's weaker and unused for 43 years was a real risk. Still, the mission team proceeded, determined to reach the spacecraft any way possible. Just like the challenges it's overcome over the years, this recent issue highlights the resilience and adaptability of both the spacecraft and its engineers. Every time Voyager 1 reaches another milestone, we're reminded that human curiosity knows no bounds. This mission proves our enduring quest to explore the unknown, one signal at a time. As Voyager 1 continues its journey, it carries not just instruments, but humanity's message to the stars. If you're as fascinated by space exploration as we are, support our channel, subscribe, and stay tuned for more incredible stories from the final frontier. Following the October command to activate one of Voyager 1's heaters, the spacecraft's automated fault protection system unexpectedly took over. This system, designed to safeguard against power strain, responded by switching off non-essential functions, including its primary X-band transmitter. Typically, this system activates only under critical circumstances to conserve the limited energy available, particularly as Voyager 1 now operates with less power each year. It was a protective response from a probe that has traveled so far. Its own mechanisms act almost as a survival instinct, choosing preservation over operation. When the NASA team received no response to their command, it was clear something unusual had happened. Initially, they believed the delay could be a typical lag due to distance, given that it takes nearly a full day for commands to reach Voyager 1 and another to receive data back. But as days passed with no signal from the X-band, the team grew concerned. Voyager's silence was unsettling. A spacecraft that had faithfully communicated for 47 years had fallen unexpectedly quiet, and with every passing hour, the risk grew that this issue could mean the end of its mission. Their next step was to check the backup S-band transmitter. The transmitter hadn't been activated since 1981, when Voyager was still within the solar system and was much closer to Earth. The S-band, unlike the X-band, is weaker and transmits with a significantly fainter signal. Given the spacecraft's current position, more than 15 billion miles away in interstellar space, the S-band was not an ideal channel to use. Its power is lower, and it was uncertain whether even the most sensitive receivers on Earth could detect such a faint signal. Nevertheless, the NASA team proceeded with cautious optimism. They carefully transmitted a command to the S-band transmitter, hoping to locate even the faintest trace of a signal. This effort would test not only the probe's responsiveness but the team's ability to manage technical hurdles nearly 50 years after launch. After days of tension and careful calculations, the NASA team finally received a faint signal on the S-band transmitter. It was an incredible moment, as this transmitter had been dormant for over 43 years. The signal was weaker and less stable than what they were used to with the X-band, yet it was unmistakably Voyager 1 reaching back across the vast gulf of space. The spacecraft, now well over 15 billion miles from Earth, was not only still operational but had managed to switch autonomously to a backup mode that would allow communication, even if only barely. For the mission team, this achievement was akin to reconnecting with a loved one after a long separation. Voyager's resilience, despite decades of exposure to cosmic radiation, the wear of time, and the immense cold of space, spoke volumes about the craftsmanship and foresight embedded into its design. The switch to the S-band transmitter wasn't just a matter of flipping a switch, it involved recalibrating the deep space network on Earth, which needed to refocus its giant radio antennas to pick up Voyager's fainter signal. The DSN's powerful dishes are scattered around the globe, and all three locations, California, Spain, and Australia, had to coordinate to lock onto Voyager's weakened transmissions. Each of these antennas, towering structures of steel and circuitry, became part of a finely tuned effort to maintain contact, shifting as necessary to ensure continuous tracking. These adjustments were an impressive feat, highlighting the incredible lengths the team is willing to go to keep Voyager's signal alive. This shift to the S-band transmitter is a reminder of just how far Voyager has traveled, not only in distance but in resilience. When the mission was first launched, the team could scarcely have imagined the craft would still be active nearly 5 decades later. It was designed with redundancy in mind, but those redundancies are being tested beyond anything anticipated in the 1970s. This particular issue underlines the challenges of operating such an old spacecraft. Unlike newer probes with more flexible software and systems that can be updated from afar, Voyager relies on its original 1970s technology, with only pre-programmed commands and protocols to safeguard it. Now that contact is re-established, the team is gathering data to better understand what triggered Voyager's fault protection system and whether it could happen again. They must weigh each decision carefully, as every command could either prolong the mission or unintentionally cause further issues. Voyager's instruments, power supply, and systems are all balancing on the edge, pushing human ingenuity to its limits as the spacecraft ventures ever deeper into uncharted space. The team faces a delicate dance, with every maneuver critical in deciding how much longer Voyager can continue sending back its remarkable findings from beyond the solar system. With contact restored, NASA's flight team shifted focus to understanding the chain of events that led Voyager 1 to activate its fault protection system and switch to its S-band transmitter. It's a complex task, as every subsystem on Voyager has been working at reduced capacity for years, stretching well beyond its anticipated operational life. The spacecraft's nuclear power source, a radioisotope thermoelectric generator, RTG, is steadily depleting, and each year it provides slightly less power than the year before. This gradual power loss has forced NASA to make difficult decisions about which systems to keep running and which to shut down. They must balance data collection with survival, ensuring that Voyager's core instruments remain functional as it drifts further from the Sun. One of the core challenges is that, unlike Earth-bound technologies that can be modified or reset with a few commands, Voyager's original systems are immutable relics of 1970s engineering. They run on hardware that cannot be remotely updated or altered, making every command a high-stakes decision. The team has to consider how each directive might impact other systems and whether any unexpected reactions could again trigger Voyager's fault protection. For instance, they must factor in the effects of operating in extreme cold, as the spacecraft is exposed to near absolute zero temperatures in interstellar space, a stark contrast from its initial travels through the solar system. In addition to the power concerns, the degradation of Voyager's hardware presents another unique set of issues. The spacecraft's thrusters, responsible for orienting its antenna toward Earth, have shown signs of wear, requiring extra care in their use. Without precise orientation, Voyager's signals would scatter into the void. Even slight misalignments could jeopardize communication, cutting off the mission entirely. To compensate, the team often sends carefully timed commands to ensure Voyager's instruments continue facing Earth, despite its gradual drift and the increasing strain on its aging systems. The significance of Voyager's journey is underscored by the fact that it operates in a region of space unlike any other probe has explored. In interstellar space, it encounters particles and forces that are largely unfamiliar, providing a unique glimpse into the environment beyond our solar system's protective heliosphere. Each byte of data transmitted across billions of miles is an invaluable insight into this largely unknown region. Voyager 1's instruments continue to detect cosmic rays, charged particles, and magnetic fields, helping scientists understand the boundary between our solar bubble and the wider galaxy. Yet, every new problem Voyager encounters is a reminder of its age and the increasingly narrow margin it operates within. The mission team faces an extraordinary challenge, maintaining Voyager's delicate systems, operating at the edge of technical possibility, in hopes of gathering as much data as possible before the spacecraft finally succumbs to the inevitability of time. The journey of Voyager 1 is not just a testament to human engineering but a profound symbol of our enduring desire to explore, learn, and reach beyond the visible horizon. As the team continues their work, each signal received is a moment of triumph, proof that even against enormous odds, Voyager is still on its mission, relaying secrets from the edge of interstellar space. Voyager 1's journey into interstellar space is not just a technological marvel, it's a profound reflection of human curiosity and resilience. Every byte of data it sends back offers a rare glimpse into a realm few thought we'd explore so directly. This spacecraft, built with 1970s technology, has become an icon of perseverance, embodying our relentless drive to understand the cosmos. Its mission extends beyond science. It speaks to our desire to reach out into the unknown, to explore, and to leave a legacy that defies time and distance. As the spacecraft ventures deeper into the vast emptiness beyond our solar system, its survival grows more tenuous. The team at NASA carefully weighs each command, knowing that one misstep could silence this emissary from Earth forever. But they proceed, trusting that every additional piece of data Voyager sends will expand our understanding of the universe. It's a pursuit that requires patience, precision, and optimism, qualities that Voyager itself has come to represent. Voyager 1 reminds us that exploration is a journey often marked by obstacles and uncertainties, but it's also a path filled with extraordinary discoveries. Each challenge faced and overcome brings us closer to answering some of the most fundamental questions about the nature of our universe. Voyager's story is an enduring testament to the idea that when we push beyond known boundaries, we discover more about ourselves and our place in the cosmos. As we continue to receive Voyager's messages from the stars, it's a powerful reminder of how much remains to be discovered. If you believe in the spirit of exploration and the value of these ongoing journeys into the unknown, support our mission to share these stories. Subscribe, stay curious, and join us as we continue to reach for the stars.